Okay, hello. So, back to design of experiments. We've been talking about pair of t-tests, and those are mainly in chapter 2, simple comparative experiments. In the book, they're going to go over far more complicated concepts. The concept that I'm going to go over today is Introduction to Factorial Designs. Now, there's chapter 3 and 4 in between that, which is regarding some single factor content, like the fixed effect model for single factor or the random effect model for single factor. I will go over those in separate videos. Please check those out when they come out. And chapter 4, mainly the thing you need to focus on is the randomized blocks. So let's go to chapter 5. Chapter 5 is talking about the factorial designs. Chapter 5 incorporates law of content from chapter 3 and 4. And so before even worrying about chapter 3 and 4, we can take a look at that parallelism and how everything is applied in chapter 5. Now let's look at 5.1. Here they're talking about the factorial designs, which mainly consists of it always consists of 2 or more factors. And that is why it's not in chapter 3, because everything was isolated in one factor. And a factor contains many levels, but you may have heard of the term treatments. Treatments and levels are the same thing. So a single factor can also have many treatments and many levels. That's if and only if statement. If a treatment has many levels, then the treatment has I'm going to fix that. If a factor has many treatments, then the factor has many levels. And then here, it's important to know that when factors are involved in this factorial design, since there are now multiple factors, it's going to be crossed. That's just a term we use, and when we find an effect that's important, we call it the main effect. So these 2 drawings here confused me a little bit at first because I wasn't sure as to what these were to represent. Mainly is just trying to show the different combinations, where you can be low for factor A, low for factor B, and then have this value of 20. Whereas here you're high in factor A and low in factor B, and then you have 40. Now the advantage of this is to calculate average response increase for either of these factors. So let's say you want to find the average response increase for factor B. Then you would go, so you care about the high average minus the low average. So high average involves these 2 terms, and we all know to create an average of 2 terms is to sum the 2 terms and divide them by 2. And then the average of the low terms is with the same computation algorithm of adding 20 plus 40 and dividing it by 2. And here is what they did, they got b equals 11. You can do the same thing without losing generality to factor A. And now moving forward, we want to note how this relates to the term interaction. The reason why we care about interaction so much is they're something that's not covered in the single factor case, right? Because single factors only have one factor, so they can't have, because an interaction by definition has 2 factors. So here, using figure 5.2's data, they made the data more extreme so that the differences would be expressed in a way where it's clear that A from the low level factor B and the A effect from the high level of factor B are very different by like 58 points. And that's just to show the interaction sign. I did do the interaction between these 2, like calculating for the interaction, and in figure 5.1, the difference is 2, so that's much smaller. And it won't really show the point of what they're trying to show, because as you can see, these are two relatively large numbers, and they have a sign change. So that's why they did that, to really stress the case. And this is the conceptual drawing to show figure 5.2 at least. I believe it also goes for figure 5.1 based on the calculation I just discussed. You can try that, and if you have any questions, feel free to comment below. Sorry about that. Now, if you've taken a linear regression course, you can use the linear coefficients like beta, b1, b2, b12, and such. But here we're more focused, at least I'm more focused in using factors and using sum of squares and less on the linear models. So here, these are some things that you may want to check out on your own. So that was just the brief gist of factors, and I hope it gives you a good idea.